We are the Adjustable Acetabular Cage Group sponsored by the Hershey Medical Center. We were tasked with developing a method to allow for adjustability between a shell and an acetabular cage during hip replacement surgery. The following animations will explain the surgical process, our objective, and what we designed.
For our project, we are looking at hip replacements for patients who have severe damage to the socket of the hip joint called the acetabulum. The first part of the replacement is called a cage, which will be placed into the acetabulum and screwed into the surrounding bone. The second part of this construct is the shell, which is placed inside the cage. Next, surgeons will try and find the proper orientation for the shell based on the patient's anatomy, and then they will cement the shell into the cage with bone cement. Once dry, the trial liners, which hold the femoral head, can be pressed into the shell, and the mobility trials can be run to see if the construct has the proper orientation for the patient. If it is not in the right position, the liner has to be removed. Because the shell was cemented before having a way to test the orientation, surgeons are forced to tediously scrape out the cement to adjust the orientation. Removing the hardened cement is difficult and very time-consuming. After surgeons have scraped out as much cement as they can, the process is repeated until the right orientation is found. Like the old implantation process, we start with a damaged pelvis and a cage. Our model has adjusted the cage to have holes to help adjust the orientation of the shell. Once the cage has been screwed into the pelvis, we can place the shell into the cage using a screw and a new hole in the center of the shell. Once a screw is screwed into one of the holes in the cage, the shell can be press-fitted onto the screw, and the trial liner can be placed in, and mobility trials can test the orientation. If the orientation is not right for the patient, the liner and shell can be taken out of the cage and the screw can be repositioned. This process can be repeated until the right orientation is found. After the right orientation is found, the liner and the shell can be removed one last time so that the cement can be added, and the shell and the final liner can then be permanently placed into the cage. Being able to reposition the components of the construct without using the cement makes the process more efficient for the surgeon and safer for the patient.
Now, we're going to show you how our device solves the surgical problem with a real-life prototype. Just like the animation, the construct will be assembled like so. The cage first, the screw attached to the shell, and the shell into the cage. Once the construct is assembled, mobility trials will be performed by placing the femur into the shell and moving it around to different positions. If this location of the femur seems likely in this position, the surgeon can change the orientation of the shell by removing the shell and putting it in a new hole. This can be repeated until the right hole is found. Afterward, the surgeon can cement the shell into the cage and the surgery can be completed.